Yeah.
Tough.
Can I get my laundry?
Echo! Did they stick around with that gas one?
No.
Oh, that thing just like my-
All right. Questions on the homework before we grade it?
Guys, you want a pencil?
All right. Everyone needs to cease the talking so that we can all hear each other. All right. Kaylee, what was the number? Okay, let's take a look at number 14. Number 14. Now the goal was, gave you an equation, you graph the line, yes? So 357, number 14. It says refer to the diagram on 356, the previous page. I answered this for someone. And it says 14, a point on the negative y-axis. Now, if Rowan hadn't destroyed my chart, I would pull that down. It would make a whole lot more sense. But let's think this through. All right. X, Y, yes? It says a point on the negative y-axis. Where's the y-axis? Where's the negative land? So I want some point on from here to there. What point is there? Point to it. Done. All right. Anybody else? Okay, let's grade this. Here we go.
Just a random number on the negative axis.
No, they had a dot right on it. So there was a point P was located right there.
How would you grade 2 through 12? It already gives you the points. You just have to like.
Well, they're specifically asking you just to plot the points. So are you asking how you grade it?
Yeah, how would you grade that?
Oh, I can't. So 2 through 12 are evens, 2 through 12s, and I got to look at what you wrote. All right, so we'll pick it up on number 14. Well, Kaylee already told us the answer. It's P. Number 16 is G, F, and Y. It doesn't have to be in that order. Number 18, apparently they were spelling words, J-O-E.
Joe.
Number 20, X and E's. Number 22, D-L-O. Number 24 is just B. All right, the rest of them are graphs. I will grade your graphs. All right, hey, the way you keep your head above water this chapter, it's not as challenging as the previous one. If you do your homework, all of it, if there's something you don't understand, you come ask questions. You don't blow it off. You do it, you give your best shot at doing it every single night. Granted, there will always be some questions you don't, that's fine, that's what math is like. But you don't blow off the homework. You do it. That way we're not at the end of the chapter and you're like, I really don't know anything of what we've done. Okay? You can clearly be lost or clueless at portions of this, and that's fine. But we fix it then. We wait to the end of the chapter to fix things. It's just too late at that point. There aren't enough days to fix it at that point. Are there any questions on this homework? You feel confident with this? Like good.
Can you explain number 22?
22, the points having opposite x and y. So if I tell you 5, what's the opposite of 5?
-5.
So you're looking for 5, -5, or whatever the
Well,
number
D
is.
and Z were opposite and I and P were opposite.
By the way, let's just do two opposites. So 5, -5, what's the opposite of this?
What? What's the opposite of 5 and -5?
-5, 5.
Oh.
So here are 2 points that are opposite each other. Yeah?
Oh, okay, I see what I did wrong.
And what was that number?
22.
And there ends up being 3 that have opposite coordinates, right? All right. What? We're moving on to something that you did. If you had a good pre-algebra teacher you did last year, you may or may not. If you had me, I did not teach you the formula to do this last year.
Okay, I'm not
year we
gonna
did this
have-
by hand. So big picture. You can remember the slope formula from last year. I'm going to teach you nothing. By the way, I didn't teach this to you. Right? If you some books introduce students to the slope formula, pre-algebra.
I know this.
Our particular one does not. Now, you may have noticed a coincidence, but our book doesn't, or the book that we teach from doesn't do the formula until Algebra 1. I never learned it until Algebra 1 either, so don't feel like you've been cheated. I will say, if there's a formula that kids screw up, boy, is this the formula that kids screw up. All right. Nothing going on until next Tuesday. We will do a quick review. On Monday, the review will be just like the quiz. You should be able to get an A on this quiz. All right, here's your homework for tonight. Thank you.
That looks not fun.
This is all pretty quickly done. Pretty quickly done. If there's a formula that kids screw up in Algebra 1, it's today's formula. A seemingly easy formula. But boy, okay, I have plenty of formulas where kids don't understand what they're doing. Every kid will understand this formula. Like, there'll be no one here that's clueless. But there will be kids that mess it up. And you'll see why here in a second. Yeah. Say again?
Should we bring graphic?
No, because this is all calculations for today.
So
Slow. Okay. Thank you. All right. So that's a pretty bold statement. This is the one form that kids screw up all the time. You're going to see why. At the very, very, very end of the year, we get the longest formula you've ever encountered. It turns out most students do pretty good with it. This is a pretty short formula, but boy, do kids screw it up. I know why they screw it up, and I'm going to try to help you so that you don't screw it up.
Are you going to give it to us the first off?
Here, did you steal that?
All right, here we go. The class is entitled Slope of a Line. So how many people right now already know how to calculate slope?
I used to remember.
You had, that's not the formula, right? But it has something to do with it. Okay, we will get there by tomorrow, that particular formula. All right, cool.
What? Oh, off-topic statement. You just untied a double-knotted tie your shoes on my shoe.
Congratulations, you win nothing. All right, now, because this word is on every single test, we're going to start off with this. It's 3 words. Rate of change.
It's a big 3.
Rate of change, and by the way, yes, when you're taking the NWEA test 3 weeks ago, it was on there. In fact, they said calculate the rate of change, and some of you were like, well, I have no idea what that is. Here's what they meant by that. Write this down. Rate of change, box 1. Rate of change is literally the relationship of 2 changing quantities. That means 2 things are changing at the same time. What's the relationship? Right. What's the relationship? We get to define that relationship. It wasn't me that decided to define it using division, but it's been decided that the relationship will be used, a fraction. We could have said it's multiplication. We decided not to. We're using division. So it's going to be 2 numbers that are changing. For instance, as you get older, you get bigger. 2 numbers. Your age is changing, your height's changing. 2 numbers that are constantly changing.
I didn't know your height would change.
This is why you're not 12 inches tall anymore.
I'm 4'11" since 4th grade.
Well, you're taller than 12 inches. At one time, you were 12 inches tall. All right. We are going to define it as a fraction. Okay, now here's where we go into algebra land. You just got to stay with me. It's not that complicated. It's a fraction. That's not complicated, but the fraction is. The fraction, you don't need to write this down. You just need to look and understand. The fraction will be determined by the dependent variable, that's either x or y, divided by the independent variable. That's a mouthful. It's an easy thing to remember. You have it in science class and you get it in math class. Okay, math symbols, science symbols. That's way too many words to write, so we can use symbols to represent this. Here are the symbols.
That delta.
The triangle, which is the letter D in Greek alphabet, delta, has been used by mathematicians and scientists as representing change. I don't know why they chose that letter, but that's the letter for change. So literally when you see a triangle in a formula, unless geometry, we call it the change in y, that's the change in the dependent variable, divided by the change in the x. In other words, it's y over x. But it's not the letter y over the letter x, it's the change in your y values over your change in your x values. That's how we're going to find rate of change. Sounds way complicated. It is simple. Okay, let me show it to you. This is what was on your test. Computers, I saw it on everyone's computer screen. They gave you a table. We call this a T table because there's a T right there, right? We call it a T table. You get a string of x coordinates, you get a string of y coordinates. These are points. Point, 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 point. And they'll say, at least on the test, on tonight for homework, calculate the rate of change. Okay? It's delta y over delta x. Okay, so how do you actually do it? Here's the process. When you're given a table and you're asked to calculate rate of change from a table, you pick 2 points. And by the way, you can pick any 2 points.
It's going by 3.
Okay? Pick any 2 points, right? So we pick any 2 rows because a row is a point. 3, 9, 2, 6, 1, 3. So we pick 2 points. Okay. I'm going to say that's my first one and that's my second one. I just randomly chose 2 rows. It says find the change in y. What's happening with my y's? Am I getting bigger or smaller?
Bigger by 3.
Okay. But if I choose this, I'm getting bigger by 3.
Wait, are you doing that?
We did do this last year, right? I need to calculate the change in y, so that's what I did. So 6 minus 3, you just told me it was 3, right? Yes, we're getting bigger by 3. 6 minus 3. What are the change in x's? What's happening?
1 plus 1.
And the x's go on the bottom, so 2 minus 1 is 1. She already told me the answer 5 minutes ago. The answer is,
3 over 1.
now how did she do that so quickly and it took us 5 minutes of a crazy calculation?
This is going 3, 6, 9, 12, 15.
And the problem is, what if this number was 11 and this was 221? No,
Oh, 11's not.
Right? But this one would have been 310, and now all of a sudden her method doesn't work. So that method of just looking at the y's works great if the x's go by
1.
ones, and that method will work. Don't throw that method away. That works great. But when you don't go by ones in your x's tonight for homework, you can't use that. You got to use this method. So the method is you pick 2 rows. You find out if you're going up or down by how much for your x's. That's just 6 minus 3 over the change in x values. By the way, this will work whether we chose those 2 or any 2. Just because I chose these 2 and I got 3 over 1, that will happen no matter what I pick. Okay, watch this. Chris, pick a row.
3, 9.
Give me another one.
4, 12.
What?
4, 12.
Wait. Be creative. Pick a different one.
2, 6.
More creative.
5, 15.
Thank you. Well, the ones next to each other, everyone sees is going up by 3. All right, it's still the same process. 15 minus 9. Not 3. But when you do 5 minus 3, you get,
2.
which is, it doesn't matter which 2 rows you pick.
You
That
could
was
also
really
just
loud.
divide it.
What?
You could also just divide it.
Coincidence.
Oh.
If you're going by 1.
All right.
That was really loud.
Sorry.
Yelled for no reason.
I get excited about that. All right. So it works whether you chose that 2 or any 2, right? Chris chose them at random after 5 tries. All right. Good? All right, let's do box 1 quickly. Hey,
Say 1.
if they are going up by ones, you can use that trick, but just remember, they won't always be going up by ones. But if they are, you can certainly use that trick. By the way, it's the same one. You don't need to do this one. I was just showing you that we could pick any 2 rows. Now watch, if I pick these 2 rows, first, second, Hey, by the way, this will also work if you do the subtraction in the opposite direction. Instead of doing 15 minus 9, I could do 9 minus 15. What's 9 minus 15? You guys do the same pattern. What's 3 minus 5? But that still equals, see what I mean? So it doesn't matter the order. It doesn't matter whether you do top minus bottom or bottom minus top, but once you set that pattern, you got to stick with it. Okay. There's the math on it. Okay. All right. Now here's a different one. Hey, notice. Oh, darn it. We're still going by ones.
I know it is.
Yeah, but do it this way. All right. Aiden, pick 2 rows. Doesn't matter.
1 and 5 and the bottom one.
Okay. Smart student would pick what?
The 2 negative.
What do we hate?
Negative.
Don't pick one with negatives. Well,
Yeah,
there's none of them up there, but if there's a 0 involved, yeah, pick that one.
I actually want to pick number 4 and 5.
Me personally, if I had to choose, it would be these 2. The smallest numbers and everything's positive. There's less chance of me screwing it up. But it will work, the ones he picked. Okay.
I know the answer.
Which one you want? First, second, what? This is
I
the
want
first?
4 and 5.
Yeah, but no, we're going with the ones you picked. So this first or second number that you picked? Okay, so it's this minus this. So it's negative 5 minus 11 over, same pattern, 1 minus 5. I wrote up minus. Okay, negative 5 minus 11,
Something.
1 minus 5,
16.
negative 4. What's negative 16 divided by negative 4?
That's
Positive
that's
4.
That was the answer I got.
Positive 4.
I didn't do it like that.
Yeah, but I want you to be careful. What she said works great if it's going by 1. If it doesn't go by 1, that technique doesn't work. Oh, look, he's just going up by 4. If this goes up by, this one goes up by 3, this one goes up by 62, this one goes up by 7, it doesn't work. You have to use this method. Guess what happens tonight for homework? They don't go up by 1s. So you got to use this method. Who's lost on what we just did there? Oh, by the way, let's see what I picked. I picked those 2. 7 minus 3 is 4. 4 minus 3 is 1. I get 4 over 1, and we got the same answer. It doesn't matter which 2 you pick. It doesn't matter the order of subtraction. But once you pick 2 and you pick a pattern, you stick with the pattern.
Once
Who's
you pick
lost?
2, stick 2. Stick
Yeah.
with it. Yeah, that makes sense.
And like I said, the smart student is going to avoid negatives at all possibilities. That's where you're going to make your mistake. Because if we subtract a negative that changes to a positive, boy, there's a chance to screw this up. We still got 4. All right, are we good? Calculating rate of change. There's only a couple of those tonight for homework.
Oh my gosh.
All right, where are we going with all this? Well, 1 negative 5 is actually all of these are points. Last night for homework, what did you do with those points? You played connect the dots. You made a line, right? These come from a linear equation. Rate of change in a visual form is not called rate of change. It's called steepness of a line. We will define that as the word.
Slope.
Is anyone that's the first time you ever heard that? Rate of change. Hey, we have a rate of change of 4. If you graph this graph, the steepness of it is also 4. And we call that concept of how steep a line is slope.
Why is the go back?
So
Why is the graph wrong compared to the x and y?
It's not.
so basically this equation is to find how
1,
the steepness
negative
of the
5,
line-
Oh wait, never mind. I looked at it wrong.
2, negative 1. Say again?
So that equation is to find the steepness of that line.
It's not an equation. Those are just points.
Well, yeah, but like the thing you do to define like
Somewhere in the equation will be the slope. We'll find that out tomorrow, what she was saying earlier. Right? But for right now, today, we're just going to be calculating slope. And we will be using 2 methods. 1, if they give you a graph, we can use a visual method. And then 2, if you don't have a graph, we're going to have a formula.
But none of
slope.
the homework has a graph.
So guess what you're going to be using for everyone for homework?
It's formula.
The formula. All right. So slope is just a measure of steepness. That's it. When we live in Colorado, we have ski slopes. They're not flat. You go nowhere, right? The only reason why you go down because gravity and there's steepness to it, right? So write this down, box, whatever we're on. Box 4. Don't write that down, right? Even though it's in yellow. This is what's in your book. It defines slope as the vertical change, that's the y's, delta y, over delta x. This is in every single math book that's ever existed. No math teacher ever teaches this form. Anybody remember from last year?
Yes.
Slope is called, for all math teachers,
We know that.
starts with the letter R.
Ratio?
There are kids in here who have brothers and sisters who are, so please don't use that word, right? All right.
What?
Someone said something very rude over there and I corrected them.
Run.
All right. We're going to be using something called, write this down in yellow right here, rise over run. Right. I knew somebody was saying it. Good job remembering that from last year. Now, this is in the book. If you open it up, you're going to see this. You will not see rise over run, but vertical is how much it's changing vertically. That means rise. Well, horizontal means left and right. That's how much it is running across your paper.
Oh, that's easy.
Right.
That's easy.
How do you remember the order, though? Well, you got to rise up out of your bed before you go for a run. That's kind of weak, but I've heard other math teachers say that, and it makes sense. Rise over run. It is also alphabetical, top to bottom. Rise comes before run. There's two methods of remembering it. Every math teacher from now on that you encounter, whenever you count, by the way, you'll count half of the book of calculus is about slope, believe it or not. Half of the book of calculus, 1,000-page book, half of it deals with slope, if you guys ever take calculus. So you're going to hear this forever. Every math course, whenever you use slope, you'll say, oh yeah, rise over run. We good?
Great.
Not a formula, though. It's just a saying. So calculating slope, I'm going to show you two methods. One is a visual method, if you have a graph. And the other one is a formula method. Oh, by the way, you get no graph tonight for homework. It's all the formula. But I do want to show you the graphical method, just so it makes sense that the formula isn't coming from space or magic. So graphical method, formula method. Here we go. Here's the graphical method. This is what you had last year. I gave you a line. I gave you 2 points. If you had me, I called this the monkey method, because I can teach a monkey how to do this. Not that you're a monkey. Okay, you remember this from last year?
Yeah, don't you go down like how many
You take your finger, you go to the first point on the left, and you calculate the rise. To go from this point to this point, do you go up or down? How many squares?
2,
You don't count the one you start on. 1, 2. So my rise is 2.
and your run is how many it is across?
Let me catch up. Rise is 2. Now I'm right here. Rise was 2. And then I count straight across. How many squares? 1, 2, 3, 4, 5.
2/5.
2/5 is your slope. That's how steep that line is, 2/5. Now, what does it mean? That means every time you go from point to point, you're going up 2 and over 5. If we continue this graph, we could go up 2 over 5, up 2 over 5. And notice I'm just extending that line, up 2 over 5. That's what slope means. Visually, and that's what the number means. It's just not just a random number. I don't know, the number's 3. What does it mean? It means that you're going up 3 over 1 every time that you move from point to point on the graph. Or that's the ratio of it. Okay. Now it says find 2 points if necessary. There are times when they don't give you 2 dots. So what do? And you must choose a point that intersects. These are called lattice points. You can't just choose any random A right here. I don't know what that coordinate is. You got to choose where, if these are blue lines, where the line crosses 2 blue lines. Does that sound familiar from last year?
I hated this.
Really? This is the easy thing. Like, give me 400 of these.
Yeah, that's why.
By the way, I went up first and then to the right. I can also go, okay, hold that thought. He said down, but I could go the run first and then the rise. I'm still going to get over 1, 2, 3, 4, 5, and then up 2. So I would go run of 5, a rise of 2. And then to further count, I don't tell this to pre-algebra students, but to Algebra 1 students, he said I could go down first. You went down, how many squares would you go down? If I went from right to left. And then you would have, but you're going in the negative direction, and you get -2 over, but what's a negative divided by a negative? It's the same thing. So it really doesn't matter. In pre-algebra, I always tell the students go from left dot to right dot. In algebra 1, as long as you understand the direction you're moving, up is positive, down is negative. Left is negative, right is positive. Yeah, just like on a graph. It is a graph. Okay, cool. Hey, I can see a point right here and a point right here. Nathan, we going up or down? From which dot to which dot? So he's going from left to right. So from this dot to this dot, we're going up how many squares? Up 1 is a +1. We're right here. Now what? 1, 2, 3. We go in the positive or negative direction? We're going in that direction on the number line. That's -1/3. Easy peasy. If we went left dot to right dot, well, then we're going down 1. That's -1. We're going right 3. Well, that's +3. We still get negative. Sorry. We're still getting -1/3. It doesn't matter. Some people like to go right to left. Some people go left to right. It doesn't really matter. Who's never done this before, by the way? You had me for teacher last year. All right. Haley remembers doing it.
You had me for teacher last year.
I know that came out really poor. All right.
You had me for a teacher last year.
All right. Box 5. Do it all by yourself. Calculate the slope.
I don't know if I can do it.
Should take you all of 10 seconds, maybe.
I don't believe in my
When a student makes a mistake on the graphical portion, it's that they count the square they start on. Do not count the square you start on.
Yeah, I'm gonna have 20 minutes to do this one problem.
I can't do it. I don't know how to do it. If I don't, I actually don't know what's going on. My head hurts.
6.
What was the gap?
Reduce.
So it's 2.
All right.
Oh, you are.
Tristan, which one do you go? Right to left or left to right? Which one do you go? Left dot to right dot or right dot to left dot?
I did right dot.
Okay, so if you go right dot to left dot, you're going up or down? How many squares?
3. No.
1, 2, 3. I'm way up here.
2.
2. So he went up 2. We're right here now. What?
And then you count
1.
6, right?
Did you go positive or negative direction?
Negative.
So what's the fraction turn into? -1/3. Now, if you did it the other way, if you went left to right, you would have gone down -2, right, +6. You still get -1/3. We got it? All right, there's your review of why and what slope is from pre-algebra. Now let's go into Algebra 1 land. All right. Quick note. Slope is defined as rise over run. This was the previous one. We went up 2, we went over 5. That was the first one we did. We got a slope of 2/5. Now watch the magic. You ready? This is where the formula comes from. Chris, you're not paying any attention. If I write this point right here, if I put the coordinates of this point, sorry, not the point. These are not the droids you're looking for. Next slide. All right, quick note number 2. If a slope goes upwards, like we read from what direction? We read from left to right. If you imagine the line as a mountain, right? And we read from left to right, are you going up or down the mountain? Positive slope will have positive numbers. If you're climbing up the mountain, it's going to be a positive number. The opposite of that would be, okay? Negative slope is going to, from left to right, look like you're skiing down a hill. Okay? This will always give you a negative number. This will always give you a positive number. What's in between a negative and a positive? What's in between a negative and a positive?
0.
So what's a slope of 0 look like?
It's just a flat line.
It's a flat, you're not skiing anywhere, right? You're stuck there, you got a pole, and it sucks. And, all right. So yeah, slope of 0 is a horizontal line. All right. But tonight for homework, they're not going to give you any graph. They're just going to give you 2 points. So here's how that works. You see the 2 points? I were to write those 2 points, right? Looks like an up 2 over 5 again, same one I just used. Now let's write those 2 points down. Oh, why do I keep doing this? The first point is -3 positive 1, yes? The second point is 2, 3. You see that? You ready for the magic?
No.
You ready? I'm going to stack the 2 points. Except I'm going to stack them in a particular order. I'm going to put the second point on top, first point on the bottom. Here's the answer. Here's the points. Watch the magic. 3 minus 1. 2 minus 3. 2 negatives turn into a 2 plus 3 is.
It's a cheat code.
So what's the formula? If I give you 2 points, what do you got to do?
Stack them.
You got to stack them and do what?
Add them.
We didn't add them. Subtract them. You got to stack them and subtract them. This is where the formula comes from. The fact that you can take any 2 points to calculate the slope, stack them and subtract them. Now, the formula doesn't look like this. It's a formula. So, calculating slope, if I give you 2 points, okay, if it's a monkey method, this is the smart monkey method, right? It's using a formula. Here's the formula. Do you remember what we did? We stacked and we subtracted the y's and we subtracted the x's. And what was the order that we subtracted them? We did second minus the first.
So it's basically the same as the first formula?
It is, right? It's still the same. It's the change in y's over the change in x's. But now we're using coordinates. So this is the formula that everyone screws up. Why do they screw it up? Because it's in a specific order. It's not first point minus second point. It's second point minus first. Remember, I stacked the second one on top, first point on the bottom. The second way they mess it up, there's negatives involved. Every single time there's negatives, there's subtraction. And the third way they mess it up, for some reason, they want to put x's and y's on top and bottom. They really want to do, I don't know, y minus x, y minus x. I don't know why. The formula is pretty clear. It says take the 2 y values, subtract them. Take the 2 x values, subtract, but subtract them in a specific order. Second minus first. Slope is equal to y2 minus y1 over x2 minus x1. Remember, this is called subnotation. When the number's below, it doesn't mean square or to the first power. It just means 0.2, 0.1. So we take the y values of 0.2, subtract the y value of 0.1 over the x value of 0.2 minus the x value of 0.1, and that's it. Okay? Couldn't I just stack them and subtract? Yes. This formula will be used in other formulas that we have in math class, which is why they don't just say stack them and subtract them. They could, right? It would work, but this one will actually give us the complete picture. It is a ratio. Now it's a fraction. You stack them and subtract them, you don't get a fraction. Yeah.
What about when they only give you like one coordinate? Like why? What if they only give you one of the variables?
Well, then you just subtract with a variable. Right. You just throw a variable in it. Okay?
I did them.
All right, so how does this work? Step number 1, and it is the most important step. I'm sure all your teachers told you this last year if you didn't have me. It's label. The way you keep from screwing this up is you label. Okay, by the way, you get to decide which is the first point, which is the second. It's your choice. Okay, if you're lazy like me, the first one's always the first point. The second one's always the second point. It could be either or. You want to say this is point 2 and this is point 1? By all means, go for it. It will work either way, but you have to determine which is point 1, which is point 2. Secondly, yes, this is the painful one. The kids that make a mistake don't do this. You're going to label each one. This is the first point. So this is the x coordinate of the first point. We're going to write an x1. This is the y coordinate of the first point, so it's y1. This is the follow pattern. This is the x coordinate of the second point. This is the What's your question? You can, but it doesn't give you a fraction. It just gives you two numbers next to each other. That's not a fraction. Okay, so here we go. Now that we have everything labeled, we plug things into the formula. The other mistake kids make, even if they label, is they literally just don't look at the formula. Hey, what's it say right here? What does it say right here? I'm not even looking.
Y squared.
It says not y squared. It says y sub 2.
Oh, yeah.
I look up here and I find y sub 2. Hey, y sub 2 is -2. So I write a -2. The very next thing it says is minus. So I put a minus symbol. Then it says y1. I find y1. Y1 is 0. I put a 0. You see what I did? What's the next thing it says to put? X2 is right here. It's 3. Minus, what's x1? You see it's not 1, it's -1. The kids that aren't paying attention, they see a minus and they see a minus. They're like, well, I guess 1 minus is good enough. There's 2 minuses there. There's a minus from the formula. There's a minus from the coordinates. 2 negatives turn into a, so this is 3 plus 1. -2 minus 0 is, so we get -2 over 4, which reduces to
-2.
negative not 2.
No, yeah, -1 over 2.
Negative a half, right? Negative 1 over 2. Are you with me, everybody? This isn't that complicated. This is one of the easiest lessons of the year. It's just that formula, taking 2 points, calculating the slope. That's it. Nothing more than that. Josie said, what happens if this is an x? You're right at x. Literally.
No, like, what if it only gave you y equals 2?
What do you mean y equals 2? Y equals 2 is not a point.
Well, no, on the book it says calculate the slope, and then it said y equals 2.
Oh, we'll talk about that here in a little bit. All right. One more time. Hey, there's my formula. Step 1 says to label. The label, you get to pick which one's point 1 point. You can go either way. You can go 2, 1, 1, 2. It doesn't make a difference. I'm lazy. First one's point 1, point 2. That way when I label it, it doesn't go x1, x2. It goes x1, y1. It goes x2, y2. Stop me if you're lost on the labeling, right? You get to pick what's first and second point. You just pick. Then you label. If this is the first point and points go x, y, then this is the x coordinate point 1. It's the y coordinate of point 1. Yes? Okay. Now we just plug in the numbers. It says y2. What's y2? Find it. I write a -1. Minus, what's y1? x2 is 4 minus x1 is 1. Plug and chug. -1 minus 3. -1 minus 3.
-4.
4 minus 1.
3.
So we get -4 over 3. We're done. The book won't write it this way. Guess how they'll write it? And it won't be a mixed number.
It'll be
They'll take the negative and they'll put it in the middle. That's perfectly fine answer. Rylan, you gonna make it? All right, let's do one. Here we go. Box 7. Hey, if you don't want to make your first one 0.1 and the second one 0.2, do it your way. You're gonna find out we'll get the same answer. I will have a lot of students like they do enough of these and they figure out, wait a minute, sometimes it makes more sense to have the first one 0.2 and the second one, it has to do with subtraction and negatives. All right, go on with your bad self. If you figure out an easier way, do it. I'm going to be lazy and stick to my method. Oh, by the way, your method is better than mine. I'm just lazy. There is a smarter way of doing this, but you really got to think ahead. Aiden, grab your pencil. Let's go. Step number 1 is label. Label your points.
You just do it in your head.
Yeah, but I'm just saying. Trust me when I say this. If you don't label it, eventually you're going to mess up and put the wrong numbers. If you label it, you at least have a chance. Labeling it takes, let's count. Count.
1, 2, 3, 4, 5.
5 seconds. You got 5 seconds.
Technically 7. We're counting normally.
But you wouldn't be concentrating on counting, you need to be writing. All right. Takes 5 seconds to label. Boom. All right. What's y2?
5,
Minus, what's y1?
2,
Okay. x2
1,
minus,
-3.
you see why I have 2 negatives, Chris? I didn't see your pencil move one time on this problem. Do this. This is how you will get this. Chris, 2 negatives turn into, what do you get on the top?
On the top, I have
What do you get on the bottom? 2 over 4. I'm sorry, 3 over 4, you're done. You tell me, easiest class of the year in Algebra 1? Pretty close.
Ratios were arguably easy.
Say again? No multiplication, it's subtraction. The formula is just subtraction. Top, subtraction, bottom. Yes, everybody? I can't make it any more complicated than this other than the Josie's question.
What is this?
All right, 15-second head start. If you really want to call the first one 0.2 and the second one 0.1, label accordingly and see that we get the same answer. Sophia, you got this? Don't say yes if you mean no. Anybody struggling to get started? I'm lazy. First one's always 0.1 for me, second one's always 0.2. But it will still work if you make this x2, y2, x1, y1. It'll still work. For me, y2, it's -4 minus -1. -3 minus 5. 2 negatives give me a positive, -4 plus 1, -3 over -8. 2 negatives turn into 3/8. Are we okay? All right, we got to answer Josie's question. All right, just remember, order matters. You can't just do it in any order that you want. You got to set the order and then follow the formula. If you just haphazardly throwing numbers around, yeah, you'll get to an answer and it'll be the wrong one. Vertical and horizontal lines. We had this conversation yesterday. Where's the horizon? It's where the sky meets the ground. And as you look out there, it looks like a line like that. That's the horizon. So when we're talking about horizontal lines, that's a horizontal line. It just pains me when people mix up vertical and horizontal. Okay. We did this yesterday, right? Horizontal line. What's the definition of slope?
There has to be.
What's the definition of slope? 2 words.
Steepness.
2 words.
Steepness of
Oh, you actually, I'm sorry, you didn't give me the right definition. What's the formula for slope?
Y.
Rise over run, and then we get y2 minus y1 over x2 minus x1. Okay, so let's do the math. Horizontal line, yes? So y2 is right here, y1 is right here. So 2 minus 2 is?
0.
And the bottom one, 2 minus -3, that's 2 plus 3, and that's 5. So I get 0 over 5. What's that answer?
Nothing.
What's the slope of any horizontal line? 0. From yesterday's class, what's the formula for all horizontal lines?
I don't remember.
Anybody remember? You wrote in your notes. What's the formula for all horizontal lines?
No. Y equals. Oh.
Tonight for homework, if it says y equals 3, what's the slope?
0.
Because it's a horizontal line.
And if it says.
Oh, we'll talk about the next one secondly. Did everybody follow that logic? Y equals k is any horizontal line where k equals where it crosses through the y-axis. So this is y equals 2. That's the equation, that line right there. You see y equals a number, it's a horizontal line. All horizontal lines, right? Positive slope, negative slope, and the middle is 0. So all horizontal lines have a slope of 0. There's no calculation to do. You put 0 and you're done. All right. Here's the calculation I just did. Right? 0 over 5. It's 0. All horizontal. Vertical lines. Okay? Apply the formula. We do y2 minus y1. Well, the y's are right here, so -2 minus 1 is -3. X2 -2 minus minus 2. Can you ever have a fraction with 0?
No.
And here's this idea of vertical slope. All right, horizontal line has a slope of 0. As it gets steeper, the number is what's happening to the number? Bigger and bigger and bigger and bigger and bigger. And eventually you get to a vertical line. Well, how steep is a vertical line?
Extremely steep.
Right? It's that fraction, right? It has no more run, right? This still has a little bit of run. It goes left or right a little bit, but as soon as it gets vertical, it has no run. This is as steep as it gets. If we move it a little bit this way, guess what the slope is?
Negative.
It's negative, right? So when you get a vertical line, what are we going to say?
No slope.
No slope, or undefined is what the book would like you to write. So for vertical lines, what's the form of a vertical line? X equals k. So if you see x equals k and it says what's the slope, they didn't give you 2 points, it's undefined. You need to write this down. These two right here, this technically was box number, whatever that says right there. Okay? Horizontal lines have a slope of 0. Don't put no slope. Did I say that right? Don't put no, yeah. Don't put no slope. Is that double negative?
No, yeah, don't put no slope if that's what you
It does
mean.
sound like a double negative there. Horizontal lines do have a slope. It's a slope of 0. It's the vertical lines that don't have no slope. No, that would mean they have a slope. Vertical lines have a slope that is undefined. I believe we had this conversation before about dividing by 0 is really dividing by infinity, right? This number gets smaller and smaller and smaller and smaller and smaller, right? Eventually it reaches 0, and that's when you can't do the division anymore. Okay, cool. If we were to have to sum this up right before the bell rings, positive or negative slope?
Negative.
Positive or negative slope? Why? It's going from left to right, it's going up. Okay, positive slope. Positive or negative slope?
Negative.
Going down from left to right, we're going down the hill. Well, what's in between them? It would be a horizontal line that has a slope of, and it makes sense. Nope. It makes sense because between positive and negative, think of a number line. Negative numbers over here, positive numbers over here. In between positive and negative numbers is the number 0, which makes sense then, therefore, what's between that line and that line? Well, if you're not there, you're not there, you're in between, you have a slope of 0. Its vertical lines are the, I don't know, the weird ones. Vertical lines, there's not a number. It's infinity, technically. It's so steep, it's infinite, right? It's undefined. There's a symbol you can also put, if you want to put that symbol. Questions on anything I did? Hey, easy class. So easy that people will make mistakes on it because that formula, y2 minus y1 over x2, x1, can cause mistakes. All right, last thing, I'm just going to point this out. Hey, this is where we're going. What's the slope?
Oh,
What?
so we do the thing that we did the other day. You have to do 2 times 0, and then it's negative 3y equals 6.
How did we calculate the slope throughout the entire class? What did we need? Listen, we needed 2 points. So if I give you a formula, how do you find 2 points?
You put y equals 0 and x equals 0.
I put in some zeros for x and y. So we do the thing that we did 2 classes ago. We plug in 0 for x. Stop, we got 2 minutes. We get to the point, hey, I got 0, -2. I do it again, this time I let y be 0. I get to another point. Now I have 2 points. Could you calculate the slope now?
Yes.
That's what you have to, I believe there's 1, 2, like that for homework.
There's 3.
3 of them, okay. If they give you an equation and it's not y equals k or x equals k, you got to pick 2 points. Hey, make your life easy, pick 0 for x and y. All right. Give them a minute and then let them go. Turn the homework away? Yeah. That's good. That's 2 in a row. All right, e-learners, if you have any questions, send me a chat or email. See you tomorrow.